Magnitude of the resultant vector using Pythagoras theorem. In the previous sections, we saw how to sketch the resultant vector r by adding the two component vectors by different methods. How can you determine the magnitude of this resultant vector? Well, we can measure the length of the resultant vector and then use the scale of 1 centimeter equals 100 Newton to find the magnitude. Here the length is 5,2 centimeters. Therefore, the magnitude of the resultant force, r, is 520 Newton. Can we calculate the magnitude without any measurements, knowing that measurement is usually prone to errors? Well, the magnitude of the vector rx is 500 Newton, and the magnitude of the vector ry is 150 Newton. Two magnitudes cannot be added when two vectors are not along the same line. Let us see if we can use some concepts learnt in mathematics here. Observe the resultant vector formed by the tail-to-head method. The three vectors form a triangle. The clue lies in the angle shown. It is a right angle, and the triangle is therefore a right-angled triangle. We therefore apply the Pythagoras Theorem, where the sum of the squares of the sides of a right-angled triangle is equal to the square of the hypotenuse. C squared equals a squared plus b squared. Here the resultant is the hypotenuse and the sides of the two component vectors. Therefore, rx squared plus ry squared is equal to r squared. We can write this equation because we are considering only the magnitude or the length of the two vectors. However, we cannot write vector rx squared plus ry squared equals r squared with arrows on top of the vectors. It is meaningless. Vectors cannot be squared. Substituting the values, we get r squared equals 500 squared plus 150 squared equals 272,500. R equals square root of 272,500 equals 522,02 Newton. Note that we have not determined the vector r by this method, as we have only found the magnitude.
Starting to feel it? Now go master it with Maski.